Okay, let's dive right in. We're going to explore a mental tool that's, well, it's so powerful it can make impossible problems just disappear. And believe it or not, it all starts with a super simple puzzle about an ant on a paper loop.
So, picture this. You've got this little ant on the outside of a paper ring, and its mission, should it choose to accept it, is to walk a path that covers both the outside and the inside surfaces. But here's the catch. It can't, under any circumstances, cross over the edge. How could it possibly do that? I mean, it seems totally impossible, right?
And yeah, conventional thinking would absolutely say it's impossible. But the solution? Oh, it's so elegant, and it all comes down to one single kind of counterintuitive action. So here's how you do it. The trick is you don't change the ant and you don't change its path. Nope, you change the world it's walking on. You just take a simple strip of paper, give one end a little half twist, just 180 degrees, and then tape the ends together. And what you've done is create something completely new.
This amazing new shape is called a Mobius strip. It's named after the 19th century mathematician who figured this all out. So what's the big deal? Well, it looks like it has two sides, right? An inside and an outside, but it doesn't. It actually only has one continuous side. And boom, just like that, on this new surface, our little ant can walk forever. It'll eventually cover every single part of the strip, what we thought were two separate sides, the inside and the outside, all without ever, not once, crossing an edge. The impossible just became possible.
Okay, so this physical twist, this little paper trick, it's actually a perfect metaphor for a mental technique that is just as powerful. We're talking about a whole new way of looking at problems.
We call it reverse thinking, and it's basically the art of deliberately swimming upstream, It's about questioning the standard default way of doing things and just asking that simple but powerful question. Hey, what if we did this the complete opposite way?
And you actually see this kind of thinking all over the place in everyday life once you start looking for it. Take addresses, for example. In a lot of Western countries, we write an address from small to big, right? You start with the person, then the house, the street, the city. But in China and a lot of other places in East Asia, it's the exact reverse. They go big to small. And here's the thing. They're two totally opposite ways of doing it, but both are perfectly logical. They both work. There's this quote from the source material that just nails it. It says that conventional thinking sees the impossible as, well, impossible. But reverse thinking, it sees the impossible as totally possible. You just have to look at it from a different structure. It's not about changing the facts. It's about changing the framework you're using to look at them. It's about twisting the paper. So, okay, this is way more than just a neat party trick or a fun thought experiment. This exact kind of thinking, it's been the secret sauce behind some of the absolute biggest revolutions in the history of science. All right, for centuries, hundreds of years, the world ran on Newton's physics. The rules were simple. Space was this fixed absolute stage, and time was like a universal clock, just ticking away at the same rate for everybody, everywhere. Rock solid. And then, along comes Albert Einstein, and he does the exact same thing we did with the paper. He applies a conceptual twist. He said, what if space and time aren't separate things at all? What if they're woven together into one single fabric? He called it space-time. And get this, that fabric could actually bend and stretch. And hey, if you think that's a mind bender, just wait. Things get even stranger, way, way weirder when we zoom all the way down to the quantum level, the universe of the super, super tiny. So down at this quantum level, we run smack into something called the uncertainty principle. Basically, it says there's a hard limit to what we can ever know. It's like a cosmic trade-off. The more you know about where a particle is, the less you can know about where it's going, and vice versa. For a long time, this just seemed like a fundamental, unbreakable rule of the universe.
But what happens if we apply our little twist? If we apply reverse thinking, we can ask a completely different kind of question. Is the particle really uncertain in its nature? Or is it possible that our act of measuring it is what's creating all the uncertainty in the first place? See, that question reframes the entire problem. The conventional view just kind of throws its hands up and says, well, the particle's path is just unknowable. But the reverse thinking view suggests, hey, maybe our tools are just too clumsy. It's like trying to measure a tiny speck of dust with a giant sledgehammer. Of course you're going to mess it up. And the implication there is, whoa, it's staggering. It means if we could just invent a new, gentler way to see these particles, the quantum world might not be so random after all. It might be perfectly predictable.
That's just a perfect example of how flipping the question on its head can open up entirely new ways of looking at the universe. And it really makes you wonder, doesn't it? What other impossible problems out there are just waiting for the right twist? Okay, let's tackle a big one, a classic from science fiction, faster than light travel. Now, as far as we know, our current physics says this is a no-go. You just can't accelerate an object with mass past the universe's ultimate speed limit. End of story. It's a dead end. Or is it? See, if we use reverse thinking, we don't try to break that rule, we change the game entirely. Instead of trying to blast through space faster, what if you could just bend space itself to create a shortcut? Or what if you twist the problem a different way and change the very structure of the thing that's traveling? The source material brings up teleportation. You're not moving a person from A to B, you're deconstructing them in one place and reconstructing them in another. It's not travel anymore. It's reorienting a structure. See the twist?
And really, that's the key to the whole thing. Just like with our little paper loop, sometimes the most profound, game-changing shifts come from that one simple 180-degree turn in how you look at something. That's what transforms a dead end into a doorway.
And that brings this whole incredible idea right back home, to us. Because this tool isn't just for physicists trying to figure out the cosmos. Think about an impossible problem you're facing right now, maybe in your work, in your relationships, whatever. And just ask yourself, what happens if I give this problem a 180-degree twist? What if the real solution is the exact opposite of what everyone thinks is the obvious answer? Go on, try it. You might just find your very own Mobius strip solution.